Alright, we'll see this example 2. Example 2 say, at A, I don't know how to pronounce this thing, I don't be Ajebo. So Ajebos, help us pronounce this thing. At A, sure now understand, party for 35 eminent people. This thing is Ajebo party. I make the carry big Oyibo put for here, one will be pronounced. You see, they don't call eminent. So I know what eminent means. Eminent means people will get APC, people will get connection. Eminent people. So we get 25 people call request fried rice. Yeah? And then 15 call request salad. And then 20 people call request for shredded beef. Don't ask me what shredded beef be. Ask your sister. Your sister from lunch up and where you take her out. So now 7 people call request for fried rice and salad. 30 people request for fried rice and shredded beef. And 8 people call request for salad and shredded beef. Also for the party, 10 people request for fried rice only, while 5 people call request for salad only. The same we use Venn diagram. Find number 1, the number of people that requested for all 3 dishes. So even the eminent Ajebo people said it's a bit chop well. Some people even chop the whole 3 food. Number 2, the number of people that requested for 2 different dishes. And then for here, the number that requested for only 1 dish. So now, this question is similar to the other one, but difference dey. For the other one, they don't give us the value of our universal set. The cardinality of our universal set, they don't give us. But for here, they give us the cardinality of our universal set. That's 37. And then they come tell us say our set na fried rice and meat. So we get rice, and then we get salad, and then we get beef.
Shredded
Beef, abi? So make I call this one rice, make I call this one beef, make I call this one salad. Anyhow wey you want, you go do am. If you say this one salad, this one beef, you no matter since you know wetin you dey do. Now the first one we go collect na our set all the people wey request for fried rice na 25, and all the people wey request for salad na 15, abi? Na 15. And everybody wey say they want shredded beef na 20. 20 people say they want shredded beef. And then they come tell us say 7 people requested for fried rice and salad. We don't know that one now. Say fried rice, salad, intersect this one. Now I need that one, huh? So we have rice, intersect salad, come intersect beef, abi? Now it be which one now? 7 people. Okay, we can't get that. 13 people come request for fried rice and shredded beef, abi? Fried rice and shredded beef. So we get this one, intersect beef, come intersect salad. 13, abi? And then from there, we can get 8 people requested for salad and shredded beef. So we get salad, shredded beef, come intersect fried rice. So there will be 8. And then which one again? They say also for this party, say 10 people come request for fried rice only. So now here we go write down fried rice only. And we sabi how to represent am abi. We sabi how to represent am abi. We will complement these two, and then we will get 10 people abi. And then which one again? They say while 5 people requested for salad only. So we know so we complement this one, salad, and then we complement beef. So they need 5. So here we get 5. So we don't represent them for Venn diagram. We say find the number of people that requested for all the 3 dishes. So which means this place. What we call this place X. Abi? We call this place X. Then if we get here, even get this place. How? How I won't get here? Remember when I tell you, I say, if I take everything we get here like this, Abi, if I come out waiting there, you get waiting there. Abi? Now, they don't give me waiting there, all of this place. Can't give me waiting there, all of this place. Can't give me waiting there, all of this place. Which is this one, and this one. Abi? So if I take waiting there, all of this place, can't come out this X, I will get waiting there here. So this place, make a 7 minus X. Abi? And then I will take with all of this place, come come out this X, I will get waiting remain. Abi? So this place now, I will take them as 8 minus X. And then this place now will be 13 minus X. So this place, go take the set B, everything we get here, which is 20. Then we go minus this one, minus this one, minus this one, we will get here. Abi? So if I cut off this part, take this part out, I will get waiting there. So for this one now, this place now, I will get 20 minus this one, 13 minus X. Then I'll come minus this X. Then I'll come minus this part, minus 8 minus X. Abi? So now we don't get everything we're supposed to do our Venn diagram like this. Now what happen now? If we assume say everybody will get this part collect at least 1 food. Now the assumption is that everybody for the question they will tell you make you assume. Make we assume say everybody will come this part take at least 1 food. That means say nothing there outside these cycles. Nothing there outside this cycle. So therefore, everything where they inside these cycles will give us our universal set. Abi? No confusion, but make we understand that. So everything, if we add this one, 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 will give us our. So we go pick our universal set will be 37. We'll add 10. Abi? 10. Then I'll go add plus 7 minus X. Abi? Then I'll go add 5. Then I'll go add 13 minus X. Abi? Then I'll go add X. Abi? Go. Then I'll go add plus 8 minus X. Abi? Then I'll go add this one. 20 minus waiting. 13 minus X. Abi? 13 minus X. Minus X minus 8 minus X. Now everything will go add that. So if you take 37, you can't give us 10. Then this one will just give us plus 7 minus X plus 5. will just give us plus 13 minus x plus x plus 8 minus x. Then we'll open this one now. Okay? We'll open this one now. 20 minus 13. This minus plus x. And then minus x. And then minus 8 plus x. Okay? So we get 37. 10 plus 7, 17. Plus this one, 22. Plus this one, 35. Plus this one, 43. Plus this one, 63. Abi? 63 minus 13. That's 50. Abi? 50 minus 8 will give us 42. So we get 42. Then we will cancel x. This x will cancel this x. Abi? And then this x will cancel this x. Abi? X cancelling this x. So minus x. Like this. So we collect like terms. So we get x is equal to 42 minus 37. So 42 minus 37, our x will be 5 back. Now, the people wey request for 3 dishes, now 5 will be. Now we go write 5 for here. So people wey request for 3 dishes, now 5. The next question say the number of people that requested for 2 different dishes. 2 different dishes. And the people wey dey here, dey here, dey here. I know say my x na 5. If I minus 5 from 7, I will get 2 for here. So I get 2. If I minus 5 from 8, I will get 3 for here. And then if I minus 5 from 13, I will get 8 for here. So I get 8. And people will request for fried rice and salad. And people will request for fried rice and beef. And people will request for salad and shredded beef. So our number 2 question now 8 plus 2 plus 3. So if we do that one, we get 13. The last question say the number that requested for only 1 dish. And these people, and these people, now they request for only 1 dish. But make we find what they here first. What will be the number where they here first? So I get 20. I get 20. Come minus 13. Come minus x. Come minus x. Come minus 8 minus x again like this. Okay? So my x now, I know say my x now 5. So 20 minus this one will give me 8 back. And then this one now 5. And then this one now 3, abi? This one now 3. So I get 20 minus this one and this one and this one. This and this one. And 8, 16. So now 4. So waiting there here now 4. Now 4 now in here. People will request for 1 dish. Now 10 plus, that's my last question. 10 plus 5 plus 4. I then request for 1 dish. So if I add this one, I will get 19. And if we don't finish, we don't answer our questions, finish. So this one now, algebraic law of sets, or laws of algebra of sets. So the first one we will get now commutative law. Commutative law says if we take A intersection B, no matter if we take B intersection A, are the same thing. If we take A union B, no matter. Say if we take B union A, are the same thing. Associative law say if we take this set A intersection C, come use and take the intersection of A, And the same thing it will be if you take A intersection B, come use an A intersection of C, both of them. So this one man say if you take A union, if you take B union C, can't use this set, take the union of this set, you will still get the same thing. If you take A union B, can't take union C. So for here, say if we take B union C, can't use an intersect A, or can't take the intersection of this set with A. Now the same thing, if we take intersection of this set with B, take intersection of A with C, can't take the union of these two sets. And the same thing will be here. If you take B intersection C, can't use and take the union of these two sets. Now the same thing, if we take A union B, A union C, can't take the intersection of these two sets. Law of set absorption. You say if you take A union B, can't use and take the intersection of A union B with A, we'll get set A. If we take A intersection B, can't take the union of this set with set A, we'll get set A. This one is indemnipotent law. Indemnipotent law says if we take A intersect A, we'll get A. If we take A union A, we'll get A. De Morgan's law. De Morgan's law says if you take A intersect B complement, now the same thing with A complement union B complement. Again, if you take A union B complement, now the same thing with A complement intersect B complement. Law of complementation say A intersect A complement na empty set. A union A complement na universal set. Universal set complement will give us empty set. Empty set complement will give us universal set. And then additional properties. This one say empty set intersect A na empty set. Empty set union A will give me A. Universal set intersect A will give me A. Universal set union A will give me universal set. These are the law of inclusion. Law of inclusion say if A is contained in B and B is contained in C, therefore or then A is in C. A will be inside C. Say if A dey inside B and A dey inside C, then A supposed to be inside B intersect C. And then if A dey inside B and A dey inside C, then A supposed to be inside B union C for any set C. I hope this class makes sense. If it makes sense, subscribe. I even write my own law, Mr. Maths law. That's my own law. Abi? All right. Thank you. I'll see you in the next class. Don't miss my next class.